Imagine a force so powerful it can erase a civilization in minutes. A silent monster rises from the depths to reclaim the land with zero warning. Welcome to the raw, unforgiving reality of our planet. This is Prime Earth. Unimaginable death and ruin are spreading across the Indian Ocean, a reality far worse than any science fiction story. Experts compare the disaster to a massive train wreck, where the front stops but the rear crushes in, obliterating everything on the coast. This event is recorded as the most catastrophic natural calamity of the last century, claiming over 250,000 lives. The world now understands what a tsunami is. But the question remains, are we ready for the next one? Numerous major cities lie in the path of danger, and it is a gamble to see who will suffer the next loss. Nothing can withstand the terrifying force of a large tsunami, but understanding its mechanics helps us prepare. Scientists are investigating how earthquakes, landslides, volcanoes, and asteroid impacts trigger these waves to better protect us. Scientists identify American cities that could be struck by massive waves at any moment. We analyze the effectiveness of warning systems and how they failed to protect the unsuspecting coasts of Sumatra in 2004. At 7:58 a.m., sunrise over the Indian Ocean marks the moment the second most powerful quake in history unleashed deadly waves. In those critical first minutes, only a few people realize the catastrophe that is about to unfold. Thousands of miles away in Hawaii, a scientist ends a long shift at the Tsunami Warning Center just as computers detect seismic signals. The seismic shock that doomed thousands appears as a simple, innocent-looking line on a chart. Earthquakes exceeding magnitude 6 trigger automatic alerts to scientists. One expert recalls receiving the alarm at home. Realizing the magnitude of the event from the distance between sensors, the scientist rushes back to the center on a bicycle. Upon arrival, colleagues are already analyzing the traces. The magnitude estimate is a massive 8.0. Calculations suggest a tsunami is racing across the ocean. But the tracking network only covers the Pacific, not the Indian Ocean. With no sensors in the Indian Ocean, the scientists know they should act, but have no regulations or contacts to call. They issue a bulletin for the Pacific, but the Indian Ocean shores receive no warning due to the lack of data and communication channels. Frustrated and flying blind, the scientists cannot see what is happening as thousands begin to die on the other side of the world. The tsunami triggered by the earthquake struck the coastlines of many countries bordering the Indian Ocean. However, the regions most severely affected were Indonesia, particularly the northern coast of Sumatra, the Aceh region, Sri Lanka's eastern, southern, and southwestern shores, India's Tamil Nadu and Andhra Pradesh coasts, including the Andaman and Nicobar Islands, and Thailand's Andaman Sea coastline, especially Phuket and Khao Lak. The waves are incredibly large, and seem to roll on forever, but their creation mechanism makes them even more deadly. Unlike normal wind-generated waves, tsunamis involve the movement of the entire water column, not just the surface. A surfer and researcher explains that while normal waves are powerful, tsunamis are fundamentally different. Normal waves slow down at the front when hitting shallow water, causing the back to pile up like a rug pushed against a wall. The power of the wave depends on the wavelength. Normal swells have crests a few hundred feet apart. In contrast, tsunami crests can be 100 miles apart, meaning 100 miles of water is relentlessly pushing behind the front. Instead of a breaking wave, imagine the entire ocean rising. This brings disastrous flooding, as seen in other catastrophes. Predicting the next tsunami depends on understanding seabed movements, like faulting or landslides, that displace water. The Indonesian tsunami was caused by a vertical jolt of the seabed that lifted the ocean column and pumped vast energy into it. The quake lasted 8 minutes and shook so violently that people could not stand. An 800-mile section of seabed flexed upwards. This vertical jolt pushed the sea up by 10 feet, creating a wave that grew to a 90-foot wall of water at the coast. The earthquake's force was equal to a 100-gigaton bomb, millions of times more powerful than the Hiroshima explosion. Researchers describe the wave as a bulldozer of water tens of miles long, destroying everything in its path. Tsunamis travel at jet speeds in deep water because energy, not water particles, is moved through the ocean. This principle is like a Newton's cradle. Energy passes through the balls with little movement of the balls themselves. A tsunami remains a silent, invisible threat until the very last moment, often passing under ships unnoticed. As the wave hits shallow water, the energy pulse compresses into a wall of water that flows onto land like a relentless river. The train wreck effect means the wave keeps pushing inland for a long time, unlike a normal wave that quickly withdraws. An expert explains that each cubic yard of water weighs a ton. Hitting with the impact of a car at 40 miles per hour. Tsunamis often come in a series of waves, sometimes hours apart, creating multiple pulses of destruction. A rock quarry experiment demonstrates how displacing water generates an energy pulse that becomes a wave in shallows. Even ripples in a pond operate on the same tsunami principles, just with infinitely less energy. Besides earthquakes, tsunamis can be triggered by volcanoes, like the 1883 Krakatoa eruption, which was the loudest sound ever heard. The Krakatoa blast created 130-foot waves and volcanic pyroclastic flows displacing water can also cause tsunamis. In 1998, a moderate earthquake in Papua New Guinea triggered an underwater landslide, causing unexpected 50-foot waves. This event proved that underwater landslides are a major hazard, capable of causing localized but devastating tsunamis. Surprise tsunamis can strike without the typical warning signs of a massive earthquake, posing a threat to coastal areas. Another threat comes from the sky. Asteroid impacts, though rare, could generate cataclysmic waves. A simulation shows that a large asteroid hitting the Atlantic could flood Europe and the U.S. East Coast inland to the mountains. While massive impacts are rare, smaller strikes are more likely and would still cause significant tsunamis. Regardless of the cause, tsunamis have always been a threat, and running to higher ground is often the only defense. Scientists are searching for methods to predict when future tsunamis might strike by studying earthquake history. Experts discovered that during the 2004 event, entire islands were tilted, thrusting submerged land out of the water. Using GPS technology, researchers can measure these land shifts with accuracy down to hundredths of an inch. The collision of tectonic plates is compared to bending a plastic ruler. Eventually, the tension releases and the land springs back. To map ancient earthquakes, scientists turn to coral reefs, which act as biological records of sea level changes. When land lifts up during a quake, exposed coral dies, creating a clear line that dates the event. By cutting into coral heads and counting growth rings like a tree, experts reconstruct a timeline of disasters spanning centuries. Meanwhile, a high-tech warning system known as DART is being deployed to protect ocean basins. These sensors are anchored to the seabed and can detect the weight of a tsunami wave passing overhead, even if it's only inches high. While these systems work for distant threats, they may be useless for earthquakes that occur very close to the shore. Over 100 cities with large populations are located dangerously close to major active fault lines. The U.S. West Coast faces a unique threat from underwater canyons where landslides could send waves crashing into tourist areas like Santa Cruz. A controversial theory suggests that a volcanic island in the Atlantic could collapse, sending a mega tsunami toward the U.S. East Coast. In the Pacific Northwest, a massive fault line capable of magnitude 9 earthquakes threatens Washington and Oregon. If a quake strikes here, residents would have only 20 minutes to evacuate before the first wave hits. Emergency managers warn that trying to drive would be fatal. People must run on foot to high ground immediately. Education proves to be the ultimate lifesaver, as demonstrated by a remote island community near the 2004 epicenter. Although closest to the quake, thousands survived because they heeded oral traditions. When the ground shakes, run to the hills. In contrast to high-tech failures, simple knowledge passed down through generations saved an entire population. Science cannot yet predict exactly when the next disaster will occur, only that it is inevitable. The best defense is not fear, but preparedness and public awareness of nature's warning signs. Thank you for watching. Don't forget to follow and like.